Okay, so me again with 2.17. And this question is, a car's velocity as a function of time is given by alpha plus beta t squared, where alpha equals 3.0 meters per second and beta equals 0.1 meters per second cubed. And question, or I guess part A, is asking us to calculate the average acceleration from time interval t equals 0 to t equals 5. So let's see part A. And once again, it gives us the equation of velocity will equal 3 plus 0.1 t squared. Okay, so to find average acceleration, for interval 0 to 5 seconds, we have to do the change in the vector velocity over the change in time, which is just v of 5 minus v 0, sorry, this is instantaneous velocity, divided by 5 minus 0, and this equals 0.5 meters per second squared. Alrighty, so part B is asking, calculate the instantaneous acceleration for t equals 0 and t equals 5. This is really similar to question 1 that I did earlier. And basically, we know, so this is what it's asking for t equals 0 and t equals 5. And we know that acceleration is simply just the derivative of velocity. So that is shown by this, which gives us 2 times 0.1 t. Alrighty, and if we evaluate this at t equals 0, we get 0. And if we find instantaneous velocity of 5, we get 1 meters per second squared. And then finally, for C, it asks us to graph both of those. So let's see what I did. For the graph of velocity, I'll do it over here. We have that it goes from 0 to 5, which is given by our interval. And it starts at 3. And it exponentially increases. That's pretty quickly. It doesn't increase that quick. More like that. And then for our acceleration, we know that it goes from 0 to 1. And then from our time interval, 0 to 5 on the x-axis. And this is a linear equation starting from 0. And that's it for 2.7.